Green, numbers. Hello and welcome to Calculus 3. We are starting this epic journey with exploration of vectors. So first we do vectors in 2D, next section 11.2 will be 3D, and then we'll do more cool stuff. So vectors in the plane, meaning vectors in 2D, we draw set of coordinate axes, x and y, and we represent a vector which will have a tail and a head. We will denote that as a vector u, let's say, with a little arrow on top. And we will immediately say that vectors are free to move in space. First of all, vectors are arbitrary. They don't exist. They're imaginary things. We use them to portray objects or phenomena like force. So you have to understand that it's something like a number. Number 7 doesn't exist. You don't see number 7 walking down the street, right? You have the concept of number 7 in your head. And if I say 7, you would most likely go, huh? Because what? 7 what? Is it 7 o'clock? Is it 7 deadly sins? Right? What is it? What do you mean 7? So the same thing, if you just say a vector, what? Right? Because a vector can represent a force, or vector can represent a person, right? If I stand, it will be a vector that it's perpendicular to the floor, which is orientation, and then the vector will be, 6'1", 6 foot and 1 inch tall or long, magnitude. So the idea is that the vectors will help us in mathematics as a concept to explain other things, to represent other things. But vectors, they don't exist, just like number 7 doesn't exist. So vectors could be n-dimensional. They can live in any space. And we will start with the 2D vectors, which is basically a review of what you should know so far from other courses, maybe physics, statics, dynamics, and so on. And then upgrade to 3D and push forward. So vectors are these entities that have direction and magnitude. Direction, theta, and magnitude, which we can call, maybe I should just put theta. Magnitude is just u. Vectors are free to move in space. Which is the reason that I can take the vector I have up there and put it right here. Now I can drop the vertical and recognize this point as 6,4. So I will say that the vector u is 6,4. Note that I'm using spiky brackets. I'm not using parentheses. So when you use spiky brackets, it's a vector. And if you use parentheses, it's going to be a point or open interval. And if you use brackets, it is a closed interval. If you use braces, it's a set of numbers. So be careful with the notation. Yes? Yes, we can use that as well. Yeah, you can use, so you can write it as a 6-4 like this as well. Usually in linear algebra, we are never going to use this notation in Calc 3. But you will use it in differential equations, and you will use it in linear algebra. So we are going to denote our vector as 6-4, and make sure you are using the spiky brackets for the notation. Also, make sure you are using the arrow above the letter, because that denotes the vector. You know that if you write x, it's just a variable. If you put x with a arrow, it's a vector. So we'll deal with that as well. So vectors are free to move in space, and orientation is very important. So if I call this a vector, it's important which way that vector is oriented, because if it's oriented this way, it works. If it's oriented this way, it doesn't work. Talking about marker pressing the board. Now, observe what I have. It has a magnitude. I can double its magnitude by simply multiplying it by 2, which makes it even a better grip, right? We can cut the marker to 1/5 of its size and then have a little trouble writing with it, but it will still be possible for us to use it. So vectors are not just free to move in space, vectors are also scalable. We can make them longer or shorter by multiplying by a value. So we have a scalar multiplication. Where we take a vector u, which has components u1 and u2 for x and y direction. And then we can say c times vector u is c times u1, u2, which gives me vector cu1, cu2. That would be our scalar multiplication. And the example, very simple example, let's say vector u is given as 3, -8. How much is 4u? Very good. Nice. So that was a quick example. We also have a 0 vector. Denoted by this, whose coordinates are 0, 0, whose length is 0. And that's technically just the dot and the origin. But we need to have a 0 vector defined, because we'll have operations that will use 0 vector. Now you can have 0 vector for 3D and 4D and so on, just by keep adding components to it. One thing that I forgot to mention regarding this scalar multiplication is that two vectors are parallel if they are scalar multiples of each other. Now, one of the basic skills is how to find a vector that stretches between 2 points. So let's have x and a y plane. Y-axis and a plane. And we pick 2 points. So what is the vector that stretches between these 2 points? What is vector AB? We are going to start by reading the coordinates of point A, which is what? Very good. And what are the coordinates of point B? Anyone? 6, 3. So what is the vector that stretches between A and B? We are going to say that vector AB is going to be vector of 6 minus 1 and then 3 minus negative 2. So vector AB is 5, 5. Now I better have 5 horizontal and 5 vertical squares. Let's check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, we do have it. So now it would be equivalent to draw the vector where you move the point A to the origin and you stretch your vector AB from 0, 0 to 5, 5, which is its standard position, because vectors are free to move. So no matter where you are, if you have 2 endpoints given, you can simply subtract the initial point from terminal, which is tail subtracted from the head. Head is where the arrow is, right? Which is going to give you the vector, which is in our case 5, 5. Now you will use this a lot to figure out equation of the plane, equation of the line. So you have to know this, start this example as a very important example, because you will have to do this a lot. You have to be able to find the vector if the endpoints are given. And you do that by simply subtracting terminal minus initial. Maybe you need to write that down as words. Terminal minus initial. Terminal point is B, that's where the vector ends. So terminal minus initial, look at the terminal, 6 and 3, there's your 6 and 3. And then minus initial, that's where the vector begins, tail part. So 1 and negative 2. And make sure you don't mess that up, right? Minus sign there, so distributes into a plus. So that's how we find the vector. Questions, concerns? Yeah, awesome. We move along. You know, I'm going to ask a question. What is the vector BA? What do we do for that vector? Yes, the points will be A minus B, and we would get what? Negative 5, negative 5. Good. Great. Now, we are going to add and subtract vectors. So say that we have 2 vectors, vector u with components u1 and u2, and vector v with components v1, v2. we are going to add or subtract vectors component-wise. Let me just make sure the stream is... Oh, it always says it's offline. Hopefully it's working. So, to add vectors, u plus v, we are simply going to have u1 plus v1, and then u2 plus v2. For subtraction, we're going to subtract those. Now make sure the order is correct, because again, subtraction is not commutative. So I want to have an example, but I want you also to graph. And the more OCD you are, the better off you are. That's how it goes. So try to be very precise. So figure out both u plus v and let's go v minus u. I want the graphs for both of those. Subtraction will be a little bit tough, but maybe you know the trick already. All right, so what are the answers? U plus v is? Very good. And v minus u? Is this good? Alex?
minus -2 is 3.
Is positive 3, yes. Your point?
Zoom in, I didn't see that.
Clearly 3, 3. I understand how stuff can be confusing. So graphs. -2, 3. That's vector u. And this is vector v. Vectors are free to move in space, so I'm going to take the vector v, and head to tail method, I'm going to move that vector v where the initial point of vector v collides with the terminal point of vector u. So vector v will be translated here it's going to look like this. And then if you draw the resultant vector, the red vector there is u plus v, and you can just count the number of squares and see that it's -1, 9. Now, how do we subtract vectors? We rewrite the problem as a combination of addition and scalar multiplication. So I'm going to write this as v plus -1 times u. Now, what is this -1 doing to u? Very good. It will flip the vector. Excellent. So what I'm going to do is, to solve this problem, I'm going to make vector u as 2, -3. So that's the first step. This vector here is minus u. And then I will add that negative u. This is negative u now. I will add that negative u to v, which creates a resultant. Now, if you examine that resultant, it's clearly 3, 3. You have 1, 2, 3 squares this way, and then 1, 2, 3 squares the other way. So it's okay. So this vector here is v minus u. There is actually no subtraction. There's also no division. It is all addition and scalar multiplication of -1. So addition and multiplication, that's all it is. Technically, and multiplication is fast addition, so it's just addition. And then we have a -1 floating around. So this is how we add. I know this is overkill, but those of you who are into electrical engineering, you will have to read those phase diagrams and other stuff. There's a lot of this type of stuff around. So understanding this sooner than later is much better. So vector components, I also want to give you the other way of writing vectors using unit vectors. We can do that. Let's do it now. No, later. So let's talk about magnitude and direction. So we already said that vector u will have the components u1 and u2, which are x and y values of how far it goes in x direction and in y direction. Magnitude, or the length of the vector, is going to be defined as the square root of u1 squared plus u2 squared. Say vector u is negative 3, 4. What is the magnitude of u? 5. Now I just want to connect this. I love this kind of stuff when you get to realize something really cool. You remember that the vector can be obtained if you subtract 2 points, right? So technically this u1 and u2 are x and y components, the difference of the points. Remember the AB example. So do you see that this is actually a distance formula? It will be like xb minus xa squared plus yb minus ya squared. It's a distance formula. Now, does that make sense? The answer is hell yes. It is a distance formula, and it's a Pythagorean theorem. It's all of it at the same time. Because if I stretch my vector right here, vector u, there is a component of that vector u, u1, and a component u2. We are using Pythagorean theorem to simply find the hypotenuse, which is the formula below, and we just give it the notation of like absolute value, but that's the notation that we use for magnitude. So you do have the Pythagorean theorem at work, but also the point here and point here at the base and the initial point and the terminal point. Those have coordinates, and if you subtract the coordinates, the formula becomes the distance formula, because the magnitude is the distance of how long the vector is. Now, that has the meaning as we start doing physics and engineering and everything else, because vector, let's say, represents, vector can represent velocity, which means, and the magnitude of velocity is speed. So technically what you're computing there is speed. You can also figure out the force, right? The force of the impact. So the magnitude of the force, and that would be, right? So two different magnitudes. the direction was the same, right? Because I hit the same spot. So the theta, which is the direction of the vector, the force was applied this way, right? So the direction of the force was the same, but the difference was in the magnitude. The first time, you barely heard anything, right? So that's what the magnitude does in terms of the force, in terms of the speed, larger the magnitude. And then now we have to discuss also the direction. So vector also has a direction, and that would be the angle that it makes with the positive x-axis. Angle theta. So theta should clearly be the inverse tangent of u2 divided by u1. Just look at the triangle, right? It's a tangent. You want to use u1 and u2 because you always have the components. Vector is given as, I don't know, 3, 7. So let's just practice this as the example. Find the magnitude and direction for 3, -7. Now, generally, you use calculator and make sure it's in degrees if it's not giving you, right, if it's not going to give you some nice value. Go on. You can use your cell phones. Even Apple. You flip it on the side. It should open up the extra thing. They figured out how to program that in. Yeah, you go. You're like, Apple, whatever. He hates it. No, the egg all came -1 is 1. You good. I don't even have to look at the if he has the whole TI-83 on it, I know it's not Apple. Because that stuff you can only install on your phone. I know. See, I see her over there using the TI-83. I know it's not Apple. Is it cold enough? Should I make it colder? You can hear the turbo kicking in, right? Yeah, bring your winter jacket. We're gonna make the Arctic cold.
So we wake up.
Yeah, no one falls asleep. Like, well, you can go sleep. Sleep. Arctic. Right? You. You're bored. Cold. Yes. Put the minus in front. The minus in front of the top function.
So it'd be like a negative of 10.
Of the positive number and whatever.
So that would be like the same thing as negative of 10 versus 10. So then the angle would be like the negative angle, so just check on those.
You're welcome. Oh, wait. It's gonna say 6.6. So I hope you guys know that inverse tangent is the odd function, which means that negative can go in front of the tangent, inverse tangent, and you can just do the inverse tangent of 7/3. You can still plug in a calculator, -7, obviously. Make sure you change the calculator in a degree mode. And what do you get? Negative?
66.8.
I was 0.2 off. All right. Degrees. So that would be direction. And if I am to graph this, negative 66.8, so let's say something like this. The length is negative root 58, which is about what, 7.7 or so? What? 7.7? And we have this angle. Good. Now the following problem is going to define annoying. Oh, hold on. No, much better.
What is the service of upsell? Talk about the service. I thought it was, I had to talk about myself. About what needs to be. I know, but then usually those like things are long. Oh, when you want to do with your life. In 5 years? Where you see yourself in 5 years, if the world needs stuff. You also feel like such a hack writing those, you know? What? I feel like a hack writing those. Like I feel like I'm lying, which I am. I know, you should. I feel bad. Should I say? Very honest.
I think that on the show leadership opportunity.
Oh God, no.
Shut up. Let me tell you about this time.
Let me tell you about this time when my math class, I had to fire a leader of our lab and take charge. So we don't score 8 or 4 points. We had to pick a I was in kindergarten. My teacher was choosing the line. It was easily the highest point of my life. Stretch it out to like 5 pages, you're good. I can't remember where I heard this, but it really struck me.
Trying to formulate the sentence. Well, she's gonna switch as soon as I go.
No, let's do it. I mean, she's pretty smart, actually. I know she's smart. Actually, I don't.
Terrible. No, this.
I don't know, to be honest.
Hang on. What's 14? I don't get to it.
First of all, that's yeah.
You can really see how interesting or pathetic someone's life is by how far back in life they actually go to reach the goal. Like, someone's like, maybe 50 talks about. I was the quarterback for between like your graduation and now there's no highlights. I don't like. I mean, high school is usually like the highest point for most people, socially at least. It all goes down. In fact, it all goes downhill. Am I right? Yeah. It all goes no. As soon as you hit puberty, it all goes downhill. No, I know it's live. So yeah, as soon as you hit puberty, or as soon as like a pet dies, because that's when you realize everything's real.
What if neither happens?
Neither. Well, I mean, it's like you out yourself right now. I mean, that's sad. All right, quickly donate. Someone donate a seat puppy. Well, you're clearly not getting puberty.
Yeah.
Well, at least you have one experience. As soon as there's a death, that's what it is. It's always fun.
All right. So we start with this one, which is what? We good there? Root 34? So 3u minus so we have 9 negative 15 minus 8 root 34 and then 14 root 34 for the final answer of 9 minus 8 root 34 comma negative 15 minus 14 root 34. Is this good?
How did you get 34?
That's 9, that's 25
Oh,
when you add them, right? Because we have a magnitude over here that multiplies. Awesome. Done deal. Unit vectors, no pressure. We are going to have the unit tangent vector, principal unit normal vector, and then there will be unit vectors that define each of the dimensions. So a lot about the unit vectors. Fact number one, it's called a unit vector because its magnitude is 1. Magnitude equals 1. The notation for unit vector is usually a hat. And you will obtain the unit vector using the formula vector u divided by its magnitude. So unit vector I is 1, 0, and unit vector j is 0, 1, and those are the base vectors for 2D. So those are your I and j. So they can help you change the notation. If you have u equals 2, negative 7, you can also write it as 2i minus 7j. So now you have a new notation for vectors which clearly separates dimensions. So what do I mean 2i and then negative 7j? That is literally stacking them up to graph. So 1i, 2i, and then negative 7. 1, 2, 3, 4, 5, 6, 7. And that will be vector u. So you can use unit vectors to decompose vectors. And each one of those is the magnitude 1. But my question is, if u, vector u, is, let's say, 3, 8, what is the u hat? You use the formula and you compute. Yeah? Yeah, 72. 72, so that's 36 times 2. So that's 6 root 2. Ah, the details. It's just one off. It's a square root of.
Are you gonna want us to write it like that with the?
Well, you have a different handwriting, so you can't.
No, like if I wrote like 3 over root 73.
You also don't use the tablet. So you definitely can't write like me.
If I wrote 3 over root 73, comma 8 over root 73, would that technically be wrong or what's up? Do you have a preference?
It's just not nice, you know. You should respect mathematics. But no, it wouldn't be points off. Why would it points off?
So you could as well write the over square root of 73.
Yeah. It will make me less happy, but yeah. I'm generally pretty happy, so, you know. Properties of vectors. Let's use blue. Properties of vectors. Number 1, addition is commutative. Number 2, we have associative property. Then we have add a 0 vector. Then we have the additive inverse. Then we have two distributive properties. C is a constant. Or if you add two constants, you can distribute that into a vector. Zero times vector v creates a 0 vector. What happened? Fast? People behind you will tell you that you have to be very particular. I saw them laughing when you asked that before I even did anything, because they all knew what's going to happen. All right, I'm done with this stuff. Which number do you need? Number 1? Here, now everyone is going to suffer. I hope you have binoculars with you. You can simply prove all of these if you just write U is U1, U2, V is V1, V2, and just chase the algebra from left to right to make it the same if you're interested in proofs and so on. So each one of these should take about 18 to 19 seconds, depends on how fast you write.
Would you say the one that we can use to just prove all these things?
Vector U is defined as U1, U2, and V is V1, V2, and you just plug them in. So I'll draft one on the board. Which one? Give me a number. 7? Nice. I know you always have my back. There you go. So you start by multiplying 0 into vector v. Vector v has components v1, v2, and you distribute 0 inside. Each component gets multiplied by 0. 0 times v1 is 0. 0 times v2 is 0. 0, 0 is 0 vector. So that's 0. Each single one gets solved by simply replacing a vector v with v1, v2, vector u with u1, u2, and then you just rearrange them and shovel them the way you would. And that's it. How's the scribe doing? Done? Awesome. You're welcome. How about some physics? I see 3 face palms in the same moment. So let's take a look at some common sense over here. This is the crate. Which way do you want to push this crate? This way or that way? Way number 1, way number 2. So, if you have something heavy, do you push like this? Observe which way. This is number 2 on the picture. Or do you push this way? Why 1?
You're not applying more force.
Huh.
You're not applying more force. You only want to make it.
Very good. You are not going to bury the crate into the ground, and if you take a look at number 2 will decompose into number 1 and also a vertical component which pushes downward. Now that's wasted because you are not going to push the crate into the ground. Now, also what you are contributing is making it worse because you are pressing down, making the crate heavier because you have the weight of the crate, which is W, and whatever force you have on that downward component is added to the weight, and all of that weight is countered by which force? Normal force, which pushes up. And what is linked to the normal force? Friction. Very good. The friction over here is a coefficient of kinetic times the normal force. So you see that if you are pushing on the crate while from the top, right, in position 2, you are making your job harder. Even though it feels like more natural thing to do, you are making the job harder because this extra component is making the crate heavier. More weight creates normal force, which is stronger, which creates more friction, right? And it's a wasted work because you are not burying it into the ground anyway. So vectors help us understand these physical processes. Now, yeah, I can go around, put some newtons, and we can do some trig and some degrees and angles and figure out exactly how much worse you're making it. But you can chase those arrows, and you will probably do that in your physics class and your statics class and so on. But you clearly see where mathematics kind of kicks in and helps you develop those ideas and push forward. So you will have that. They have a whole bunch of these problems, so try some of those. If you have any questions, hopefully you will ask next class. We will go over those, and that will be it. So that's 1-1. Questions, concerns? Well, first half of the class dismissed. I will restart the stream by